Hi everyone, so we're talking about trapezoids again, but today we're going to be talking about a really special trapezoid called the isosceles trapezoid. And if you think about what you already know about isosceles, you know an isosceles triangle, I'm writing it up here, is a triangle that has at least two equal sides. And you also know that the angles opposite the sides of an isosceles triangle are congruent. Well, an isosceles trapezoid is very similar. It's a trapezoid that has two equal legs. So the legs are equal. So an isosceles trapezoid has two equal legs. All right. And there's a couple things that are really true about in an isosceles trapezoid. In an isosceles trapezoid, so if the legs are equal, then the base angles are also congruent or equal. Now, the interesting thing, though, is that remember, there are two bases. Remember we talked about this being a base and this being a base? So if the base angles are congruent, we have these base angles being congruent to each other, and we also have these base angles being congruent to each other. Now, remember, one thing that's really important about that trapezoid is that the bases are actually parallel. And so if I gave these all letters, X, Y, R, and Q, okay, so X equals Q and Y equals R. But we also can remember that because the lines are parallel, Y plus X equals 180. And R plus Q equals 180. So those same side interior angles are supplementary. Now, there's another thing that's true about the isosceles trapezoid that relates to the diagonals. Now remember, a diagonal is a line that goes from one corner to right across to the other corner, like that. So it's got two diagonals, just like that. And the diagonals in an isosceles trapezoid are also congruent. Okay? Now, it does not mean that it is bisecting these angles, so be very, very careful to not assume that, okay? All right, so let's talk about this. Here we have an isosceles trapezoid. PQRS is an isosceles trapezoid. It wants us to find the measure of angle P, Q, and R. All right, so we know that the base angles are congruent, so that means that these angles are congruent to each other, so that I know that angle R is going to be 50 degrees. All right, now, I also know that P and Q are going to be equal to each other, so I'm going to mark them equal to each other. But to find their measure, I have to realize that because the lines are the bases are parallel, then S and P equal 180 degrees. So I do 180 minus 50, which gives me 130. So angle P is 130 degrees, and therefore angle Q is also 130 degrees. Awesome. All right. Again, the isosceles trapezoid diagonals theorem, or what I call it, the diagonals in an isosceles trapezoid are congruent. Well, so how can we use that to help us solve a mathematical problem? Okay, so let's try it. If AC, okay, so I have a trapezoid here. I'm going to tell you it's an isosceles trapezoid, okay? And diagonals are BD equaling AC, right? So we know this is an isosceles trapezoid. All right, so they tell me that AC is x squared plus 6, and BD is 8x minus 9. All right, well, this is interesting because this isn't a linear equation. So how am I going to solve it? Well, first I have to figure out what kind of equation it is. Remember, we always look at that highest exponent, and this is a 2. So this is a quadratic equation. The highest exponent is a 2, makes it a quadratic equation. Can't spell today. A quadratic equation is different. We can't solve it by balancing the equation. If it's a quadratic equation, we have to get it set equal to 0. So that means we need to subtract the 8x and add the 9 to the other side and put it in descending order in standard form. So plus 15 equals 0. Now, one way to solve a quadratic equation, and is the easiest way and the way we should always try first, is to solve by factoring. All right, so factoring means that we're going to break this trinomial up into its two factors, which are binomials. So we look at the numbers that multiply to give us a positive 15 and add to a negative 8. Now, we've learned that the pattern, if that's positive and that's negative, then these terms both have to be negative. And I know the only factors that give me x squared are x and x. So I'm looking at two numbers that multiply to give me 8, or multiply to give me 15 and add to 8. So it would be 5 and 3. So negative 5 and negative 3 equals 0. All right. Then we set each product using the zero product property equal to 0, so x equals 5, and x minus 3 equals 0, so x equals 3. So we have two possible answers. We want to make sure that both of them work. So I check. 5 squared plus 6, so is 25 plus 6, which is 31. And then 8 times 5 minus 9 is 40 minus 9, which is also 31. So that one works. And let's check 3. So 3 squared is 9. So 9 plus 6 gives me 15. And then 24 minus 9 also gives me 15. So we have two possible values of x that will work for this particular equation. And that's how you use algebra to solve problems involving isosceles trapezoids. Have a great day.